set a problem when I was out.
I didn't do it either, Chelsea. I couldn't do it without you.
She forgot.
Couldn't do it without Chelsea.
Thanks, Brandon. All right, so if you look up here and check out your number 31.
Oh, I got number 30.
Okay, it was 3x plus 5 to the 7 over 3 plus 22 equals 150. So,
Nice.
If you use the online book,
Oh yeah, it was
the problem was different.
X plus 43
Yeah.
2/3.
So you're fine, because you, like, so if you use the online
have
book,
that
your
one,
your
too.
problem is different. The answer should be 7 if you use the online book. The process is the same though. So it's the same concept, the same exact process, just different numbers in the problem.
okay, so the first thing I did is subtract 22 from both sides. And then you multiply each sides by 3 over 7, because it's 7 over 3. And then you get 3x plus 5 equals, and then that's when you have to do that thing where you put the 7 and the 3, because it's 3 over 7. And then 128 to the square root of 7 equals 2, which was on the sheet. And then 2 to the third is 8. So then 3x plus 5 equals 8, and then you can just subtract 5 to get 3x equals 3, and then x equals 1.
Good job.
Any questions for Aisha? So she had the 7th root of 128, which is equal to 2. Remember that common powers worksheet, like with all the powers on it. That might be something handy to still kind of keep out when you're looking at those rational exponents. Nice job. So Brandon is going to go over 35,
Yes.
right?
I'm so excited.
I'm
so excited. I don't know why you just said oh no, but I'm excited. I don't know.
Oh, I just didn't
You said you were missing
I feel like you're
Julia. Julia, tell me about the written Oh yeah.
That's like a big step for high school relationships.
Alright, ladies and gentlemen, if you'll give Brandon your attention, please. Okay, ladies and gentlemen, up here, please.
So 35 was x minus 10 equals the square root of 9x. So you have to get rid of the square root, so you square both sides. And then you have to FOIL x minus 10 and x minus 10 to get x squared minus 10x plus 100, which equals x squared minus 20x plus 100 equals 9x. Subtract 9x on both sides to get x squared minus 29x plus 100 equals 0. Then you have to find what times what equals positive 100, but I have to get negative 29. That would be negative 4 and negative 25. So your new equation is x squared minus 4x minus 25x plus 100 equals 0. So you split in half, and then you get x times x minus 4. Then take out negative 25 times x minus 4. So then your answers are x equals 25 or x equals 4. Plug 4 into the equation. 4 minus 10 equals the square root of 9 times 4. Negative 7 equals the square root of 36. Negative 7 does not equal 6. Plug 25 in. 25 minus 10 equals the square root of 9 times 25. 15 equals the square root of 225. 15 does equal 15, so 25 is the answer. Good day!
I couldn't hear it, I almost did it.
I so bad at
My dad was like, we are
All right, ladies and gentlemen, if you could turn to page 27, please, in your packet.
Me and Julia were talking about that yesterday. I get my it's totally gone. Doesn't do anything. I'm going to try.
Okay, ladies and gentlemen, page 27 in your packet, please.
I go drop my mom. So it's just like I don't know what to do with my dad. Like, you know, he's very
All right, so on page 27, if you look at negative 2x to the 4/3 minus 21 equals negative 53. This one is similar to the one that Asia talked about with that rational exponent. Yeah, last page. This is it for this chapter. How do you solve this problem? So what would you do, Brandon?
You add 21 to the other side.
So we want to get the x by itself. In this case, it has a radical or a rational exponent, which is okay. You're still trying to get it by itself. So using the same process to solve an equation for x, add the 21, and you get negative 32. And then, Brandon, you?
You multiply both sides by...
Hold on.
Oh, wait, you divide by negative 2.
We have to get rid of the negative 2 because x is supposed to be isolated by itself. So x to the 4/3 equals
Negative 16.
positive 16. All right, so we have negative 32 divided by negative 2 is positive 16. When you have a rational exponent, which is a fraction, the way you get rid of it is by multiplying with the reciprocal, right? So it's an exponent of 4/3. The reciprocal would be 3/4. Remember, you need to keep it as an exponent, so it can't just all of a sudden magically be a whole number. If it is an exponent, it needs to stay as an exponent. So that 16 is to the 3/4. So rewriting the 16, the 4th root of 16, the denominator is the root. The power is the numerator, so that's cubed. So Brandon, the 4th root of 16 is 2. 2 cubed is 8. So taking the 4th root of the 16, which does work, it is the number 2, and then cubing the 2 to get 8. So there is one tiny little flaw with the answer.
plus or minus.
It has to be a plus or minus. Now, you're solving for x. When you put a square root in a problem, there wasn't a square root. When you place that in the problem and it's an even root, the 4 is even, your answer has to have a plus or minus. So when you're solving for x, you're creating the radical to solve for x. You need that plus or minus when it's an even root. So a 4th root, a square root, a 6th root, an 8th root, whatever root you're working with.
So after you get the 4th root of 16, what does the 2 not stay in the parentheses then?
It does not matter. Because like
Okay.
whenever you cube something,
Oh yeah, because it's not.
because it's
Yeah,
a 3,
it's not even.
yeah. So if it was squared, then the answer would be positive if it was even. All right, so the last thing here, it does say to check for extraneous solutions. So just to check, to make sure our answers are working, if they're extraneous, remember it means it doesn't work when you plug it back in. We have a -2, and then I'm going to rewrite this as a radical. So 4/3 means the cube root of my first answer was 8, and then that's square to the 4th. There we go. So I'm writing this x as the cube root of x to the 4th, just to make it easier to simplify. Then there's a -21. Our goal is to see, does that equal -53? So starting with the cube root. Ethan, do you know what the cube root of 2 is?
Cube root of
Oh, how about the cube root of 8?
2.
2.
Negative.
And then, Ethan, 2 to the 4th is?
2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16.
Perfect.
16.
So -2 times 16 minus 21. Does that equal -53?
Yes.
Yes. So this is -32 minus 21 makes -53. So 8 is a solution. It works when you plug in an 8. If we quickly try and plug in a -8, so the cube root of -8 is -2, but any number to an even power makes it positive. So -2 to the 4th is still positive 16. Because -2 times -2 is positive 4, times -2 is -8, times -2 is positive 16. And then -21 equals -53. So this again is -32 minus 21. -53 does equal -53. So in this case, both of them work. And I think there was one problem in your homework last night where both of them worked.
Really?
Lily.
Like on the test, do we have to like show the work?
It'll state, I can't honestly remember if it says or not, but it'll tell you in the directions you must show the check step, or it'll say like, no need to show, but make sure you check.
So like if it says check for solutions, that means that we need to show.
Right, yeah. It'll definitely say one way or the other. I just can't remember off the top of my head what it says. Any questions with the rational exponent problem? Okay, so if you look at the middle problem, we have x plus 2 equals the square root of 2x plus 7. So Nina, in order to solve this problem, to get rid of the square root, what do you have to do?
Square both sides.
Square both sides. So our goal is to get rid of a radical. Well, the opposite of a square root would be to square it. So the right side is now just 2x plus 7. The radical's out of the problem. What does the left side become?
X squared plus 4x plus 4.
Good. So x squared plus 4x and then plus 4. Remember that power means there are 2 of them there. So you've got to FOIL them together. That little 2 doesn't just magically distribute through the parentheses. It means that they're a double of whatever's in the parentheses. So the process to solve this, Nina, would be to get it equal to? 0. So set it equal to 0. Because there's an x squared in this problem. So when there's x squared in the problem, we need to set it equal to 0 and to do what with it, Nina?
Factor.
Yeah, so this one needs to be factored. So x squared, if that's still in your problem, the way you solve for that is by factoring it. So we have x squared plus 2x minus 3. We're looking at 2 numbers that multiply to be -3 but add to be positive 2. And those 2 numbers are? Brandon? 3 and -1. If there's a 1 in front here, if you want to skip like that expansion step, you can. But if you still need to write this x squared minus 1x plus 3x minus 3, that's fine. But you can go to the factoring step as well. That's because there's a 1 with the x squared. So it would be an x and a positive 3, and then an x with a -1. So your 2 answers, x equals -3, x equals positive 1. Questions? So again, you need to check to see if there's an extraneous solution. So looking at the -3, taking it back, plugging it in, -3 plus 2. And then 2 times negative 3 plus 7. So Julia, negative 3 plus 2 is
Negative 1.
negative 1. On the other side,
Negative 6.
negative 6 plus 7 makes
Negative 1. Oh, it's 1.
1. So does the negative 1 equal a positive 1 because
No.
the square root of 1 is 1? No. So that's not true. That means x can't be negative 3. It's your extraneous solution. It's the fake answer. It's the one you get because you change the problem by squaring it, so you get that extra answer. Just to show you that the other one does work, 1 plus 2 makes 3. 2 times 1 plus 7 makes the square root of 9. And 3 does equal 3. So circle the one that works, cross off the one that doesn't, but do something so that when I'm looking at it, I can see that you did check it and you know that one of them is extraneous. Questions? All right, the last one is the fun one. Ah,
I hate fun.
fun. You didn't have any homework problems like this one last night. And tonight, I think there's 1, maybe 2. So it isn't, as Cooper said, it's not hard, it's just, there's a lot of the work, a pain in the butt. Is that what you said?
I said the not.
So when you square both sides, because that's still the same process, we get x plus 5. Cooper, if we FOIL the other side, we get 3x plus 4 and then minus 1. When we FOIL that, what do you get? So the square root of 3x plus 4 times the square root of 3x plus 4.
Is that just 3?
It's just 3x plus 4 because the square roots cancel when they're exactly the same.
Right.
Alright, so then we have the square root of 3x plus 4 times negative 1.
So it's negative square root of 3x.
And then add another negative square root of 3x plus 4. So that makes
Negative 2.
good, negative 2, and then square root 3x plus 4. And then the last term is a negative 1 times a negative 1 is
Plus 1.
plus 1. There you go. Any questions at this point? So, Isabella, what do you do next then? What do we have to still try and get by itself? This guy right here. So the little square root. So how could we get it by itself?
Okay, so we minus the 4, the 1, and
Yep, so she said minus the 4 and the 1. So minus 4 minus 1, they go with the whole number, and minus the 3x. So that keeps the negative 2, the radical on the one side. And then on the other side, Isabella, x minus 3x makes. And then what about 5 minus 4 minus 1? Yeah, it's equal to 0. That part's gone. So one more step to get the radical by itself, Isabella. What's the last thing we have to do? Yep. So getting it by itself, we now have the square root of 3x plus 4 and just an x on the other side. So we had to FOIL because we squared both sides. The left side doesn't just cancel. There's two quantities that need FOILed together. Took everything else to the right so that the radical was by itself, divided by 2. So now we have the square root of 3x plus 4 equals x. So what else do you have to do, Lou? Say again? Square it, right. We have to square both sides again a second time because we still don't have the radical out of the problem. So once the radical is out of the problem, then you don't have to worry about squaring things, which now it will be because if I square the radical, it's just 3x plus 4, and it's equal to x squared. Any questions? So this is the point where you set it equal to 0. I like keeping my x squared being positive. So I would choose to subtract 3x and subtract 4. But that's up to you. I think it's easier to factor when you have a positive x squared instead of a negative x squared. But I know people would rather do like just take one term to the other side instead of taking 2. But to me, it's easier to factor having a positive x squared. Then you don't have to worry about like what to do with that negative in front of the x squared. So we have a -4. We're looking for two numbers that multiply to be -4, but add to be -3. Chelsea?
-4 and 1.
-4 and 1. Bless you. So x is a +4 and x is a -1. So again, there's that step that I skipped over. So x squared plus 1x minus 4x minus 4. I skipped over that step. Questions? Go back and check it. So the forever problem is really close to being done. Just make sure that you're checking to see which one of these would be extraneous. And sometimes, like every once in a while, both of them work. Every once in a while, both of them don't work. But in most cases, one work and one doesn't. This is a 1. Okay, so Brandon, 3 times 4 is
12.
plus 4 makes.
16 is square root.
So the square root is 16 minus 1. On the other side, we have the square root of
9.
9. The square root of 16 is?
4 minus 1 equals 3, and 3 equals 3.
Good. So we know that one is the solution. Just doing a quick check to make sure the other one isn't, because every once in a while they both might work. Plug in the -1. Okay, Brandon, so 3 times -1 plus 4 is?
1.
And on the other side, -1 plus 5 is?
4.
Okay, so what's the square root of 1 minus 1?
0.
Does 0 equal 2?
No.
Nope. So 0 doesn't equal 2, that means x does not equal -1. If this was a plus sign here, then 2 would equal 2, but the problem isn't set up like that. Questions? Alright, so when you came in, you picked up a half sheet of paper with solutions on it. If you notice, not all of the problems are on there, like the left side I think is the odds, and then the right side, I don't know, there's like 6 problems on the right side too, so I kind of skipped through some of the problems. You don't have to do the ones that aren't on the answer sheet unless you really feel moved to do extra math work.
Sometimes I do like.
Sometimes you might feel like doing extra math. So again, only do the problems that the answers are provided with, those are the other problems.
Thank you.
You like one?
You can show your work on this page. Number 21, or sorry, number 20 is the one that would be the long problem. So number 20, the last one, is the one that's more involved. I'm going to start meeting with some of you, kind of seeing what you were thinking about for scheduling next year. So as you're working, I will be calling some of you up to talk about scheduling for next year.
We had a meeting with my husband this morning.
We did.
We did.
I don't think he wants me to take it.
He doesn't want to.
Yeah, he does not want
No,
to.
he's a bully and for the whole class.
He ragged on.
He just hated on me.
Did he really?
Yes, he
He
did.
was. He was on here the whole
It was
class.
hilarious.
It was awesome.
Oh, I missed it.